So, so since today will be the first session, I will be briefly introducing what actually is Python library and how it works, and then later I will give you the demo of few examples. Later we will finally conclude with a simple portal frame example, how Python can be utilized to create a structure. So let's begin.
Yes, we can see.
Yeah. So in this presentation, we will mostly see why we should be using the Python library, what are its advantages, and then we will introduce you to the Python library. So in the Civil NX, we have introduced the feature of API. So to connect with API, we can use various methods. So we can use C#, we can use any other web apps, we can use Postman, we can connect it via Excel itself. But today we are going to see how its connection with Python can be established. So normally when we are connecting with Civil NX, we need to write something called JSON. So JSON will be the file format that connects the two piece of software. So in Python, we will create the JSON file. We send this JSON file to Civil NX. Civil NX will process it and later execute whatever the data that we have sent. So here, suppose we have sent this assign one. So this contains the data for nodes. So node ID and XYZ position. But since like here, we cannot differentiate, like with a single assign key, we cannot know whether this represents a node or an element. If in a convoluted system, we do not know exactly what these key values means. And finally, this IDs has to be defined by user. So these are the three disadvantages of using the pure JSON file. So for these kind of problems, we have introduced our own Python library that contains simple functions. So for example, in order to define this node at -100, we can just write this command called node -100, and it will behave same way as this JSON file should have behaved. Similarly, this is much more clear notation. Like here, we cannot identify that this was meant for node. Here, we can clearly see that this code node clearly represents we want to create the node. There is no native, the default definition of ID. The software or the Python library will automatically determine the ID for us. And final advantage is direct auto help and auto complete. So when writing the, let's say, node, we can clearly see X, Y, Z, its ID, any structure group it should be a part of, and whether it should merge with the other nodes or not. And for X, it represent the X coordinate of the nodes. So this is the main functions. Now let's go to these advantages. So its advantage is quite easy to grasp syntax. We have various sample codes. Its reliability. So if you are writing some code that is given by us, you can be sure that the code performs the way we intend it to be, and we are regularly updating and maintaining the Python library. So at the end, we have two options. You can go with two options. So option A is using the Python library. You just have to write these two lines of code with pure JSON, where you have to write this whole JSON command. Now coming to the advantages. So now in this Python library, we have actually compared its syntax with a single beam. So if we are going to create a simple beam using pure JSON or pure Python library, the pure JSON command will took 184 lines and pure Python library will took just 27 lines of code. So that's quite a lot of reduction for a simple structure, but in complex structure, the same things will be exponential. Also, by using Python library, we can do quick edits for the model that is already been created. So suppose here we have this box section and we want to change its HO3 value and HI3 value. We can write the command to increase or decrease this HO3 and HI3 value, increase or decrease the Z coordinate of the nodes. And if we run the command, the model will be updated. So here the section is getting updated as well as the nodes are also getting translated. Next, so these are the different modules that are available inside our MIDAS Civil library. So we have this MAPI module. So that controls the interaction between the library as well as Civil NX. Next, we have this model module that handles the model operation. So it can open the model, save the model, analyze the model, set the units, etc. Next, we have node. So it will help us to determine the node, edit the node, change its group, etc. Same goes for the element material section, the group, boundary groups, loadings. So it includes the nodal load, beam load, self-head load, temperature, etc. We can define the tendons, we can define the moving load and construction stages. If we are dealing with, let's say, response spectrum analysis or eigenvalue analysis, we can also control them through analysis control window. We can define the load combination. We can extract the result tables and result images, and we can use various utility functions that are already defined. So this was all, let's say, the overall or say overview of the MIDAS library. So today we are mostly going to see the basic concepts that are applicable in MIDAS Civil Library and how it can be used to interact with Civil NX. So any question till this point? So, so we can make this session interactive. So you can ask me question at any point of time. So we will mostly going to see what these concepts are: create, get, delete, clear, and sync, and how MIDAS Civil Library incorporates them. So this is our Civil NX. So in Civil NX, to connect with any external application or to connect with API, VS Code terminal, to start writing our own code, first we need to install the MIDAS Civil library. So we can go to our documentation, copy this code, paste it, and click on enter and press enter. So this should install the latest Python library. So once it is installed, we can write from MIDAS Civil import star. So the first line actually this imports the library. Next is check. Let's see if you want to check the connection. So here right now we can see the model is in kilonewton meter units. To check what we can do, we can put model dot units, and for the time being I will change its unit to Newton, comma feet. Now let's run the code. So with these lines of code, the connection has now been established. So now we will learn some basic concepts of the library. To learn the concepts, I will again open the PPT. So first, let's see what create actually means. So create command sends data from from the Python library to Civil NX. So just to show you, I will create a node at let's say 10, 10, 10, and finally I will write node dot create. So the first line actually it defines a node at the rate 10, x equals to 10, y equals to 10, and z equals to 10. And this command sends the data to Civil NX. We can switch to work tree and we can run the command. Here we can see a single node has been created and our viewport also shows that. I can right click on the node, click on tables to see this node 10, 10, 10. So this command sends the data to Civil NX. Our next command is get command. What it does, it receives the data from Civil NX. I will delete this. I am commenting all the codes. Pause. And whatever I am getting, I am printing it. Here, this is the response that I get from Civil NX. So Civil NX sends me that you have wanted the data for node. The node has the ID of 1 and it is located at 10, 10, 10. Now, if I go to Civil NX and enter any arbitrary coordinates again and create a new node, run my Python script. This time again, I will get the updated node data. So node ID 1 was for 10, 10, 10. This node ID 2 is for my new data. So this get command get the data from Civil NX in the JSON format. So this JSON format is actually the main part here, JSON format. So we have created the data and we have obtained the data from Civil NX. Next, what we can do, we can also delete the data. If I run it, here we can see the data is now being deleted. So any doubts till this point? So I have shown you total of 3 functions for the node. The first one creates the node data. The second one gets the node data from Civil NX and third one deletes it. So If I run this command again, it will create the node data. In sequence, it will get the node data. And finally, if I leave it like this, it will at the end delete the data. So almost all the functions that are present inside our civil library, civil NX library functions in the same way. So right now I have created the nodes. Similarly, I can use this element dot create to create the node, to create the element dot delete to delete all the elements. So suppose right now I am creating a new element from scratch here. So right now I have 11 nodes, 10 elements in the Python code. So in the Python code, I am commenting everything again. I am just using this element.delete command. If I run this code, it will delete all the elements, but it has kept the nodes. If I have written node.delete command and undo it, run it, it will delete all the elements as well as the nodes. So this is how all these commands work: the create command, the get command, and the delete command. Next, let's see what actually clear is and what sync is. So I will write two node 10 10 10, node 0 0 0. So when I am writing these two commands, Python itself is creating internal data. So that stores these two nodes. So I can, so let's call this node 1. Let's call this node 2. And I am going to print this node 1 and node 2. So when I am printing the node 1 data, it shows me node 1, its XYZ location. Similarly, when I'm printing the node 2 data, node 2, its XYZ location. So this is how the Python library stores all this data. So if I show you graphically, so once you write create command, so this is my Python. So this is where my Python stores data here. This is my Python. And here I will have civil. So when I am writing any command, let's say node, it internally creates all this data here. So node, any function that I'm writing, it is creating node data inside Python, and through create command, I am sending all the data. But let's say when I am deleting the command, when I am deleting it, and civil has node. When I want to delete this node data, I want to delete the data from the civil as well as the Python. To delete the data from the Python, we have additional command called clear. So this will create, so I have defined the two nodes. I have printed the data, I have created them. Now I have removed any data that is present inside my library. If I try to create this node.clear command again, so here I only have two nodes, even though I am defining three nodes here. Two nodes at the top, I am sending the create data, and I am defining again this third node. If I remove this one, this clear command, I run the data, run the command. This time I will have total of three nodes. So when this clear command is run, it makes this forget that these two nodes even exist. So without the clear command, I have total of three nodes. Node number 1 is at 10, 10, 10. Node number 2 is at 0, 0, 0. And node number 3, that is this one, is at 0 to 0. But when I am writing the clear command, now the software forgets that there is these two nodes even exist. So this node 3 data is actually sent to, this will become my node 1 data. If I run it again and show you, so my node 1 is actually my 0 to 0. So everyone understands this concept of clear. I will show you here graphically. So first I am defining the first node is 10, 10, 0, 10, 10, 0. Since I have not defined any node number, this is internally taken as 1. Next I have defined again node number 0, 0, 0. Node definition, it is automatically taken as 2. Finally the third one, 0, 2, 0. This time it is as 3. This was my first definition. When sent to Civil NX, this will create my three nodes. Now I will do the same thing again, but when I did the clear command at this location, after coming here, I have applied the clear command. Once the clear command was applied, this node ID was changed automatically since there was no nodes. in the internal data, it automatically takes the node ID as 1. And the latest one, when it was sent to the civil, this one was taken predecessors. So final data that was given was 0 to 0, 1, and 0, 0, 0, 2. So once we will use this in a more practical scenario, it will become much more clear when to use this clear and when to use this sync command. So clear reads everything from the internal memory of Python library. Sync gets the data, executes this data, and creates the data that is in form of how Python stores the data. So first, so Prakash sir, will this be a hands-on session? So if I write code, they will be writing the code simultaneously or something else?
I think they are going to write. I mean, let me ask them how they would like to proceed. Team, would you be writing the code or just watching the watching how he writes? Say in the meeting. Uh, okay. Hibel, I think a lot of us has problem running the code, so I mean, you should continue with, and you should continue the way you are going. But I mean, we will later on when we revisit your video, we'll practice then.
Okay, sure, sir. So today we will mostly go through our tutorials and create a simple portal structure, and then if the time allows, we will expand it to creating our own alignment. Okay, so the top portion that I have written up to line 7, this will be consistent in all your codes. So now I will start by creating a portal frame structure. The portal frame structure that I am going to create as an initial demonstration will be simple. So this is my portal frame structure. I will have some dimension, let's say the height of the portal frame. This, let's say, the breadth of the portal frame, and one nodal value, one P at this node location. So in our first approach, we'll follow an absolute nodal based approach where we will be defining the nodes and then we'll be creating the elements. So here I am marking the nodes first. So this will be my node 1, node 2, node 3, node 4, and correspondingly elements. And this is my element 1, element 2, and element 3. So I will keep this image here as a reference. So we will start by creating the node 1. So this will be a node. We'll make that node at 0, 0, 0. And my input variables will be my height. Let's keep this as 10. And first model dot units kilonewton meter. I am setting the model units at kilonewton meter. So height will be 10 meter. This will be, let's say, 5 meter. And the P load value, this will be my, let's say, 15 kilonewton. I have created this node at 0, 0, 0. Since at this point of time, we like to have this granular control over the node numbers. So while defining this command, we can write the node ID directly. So comma, the ID. So ID is equal to, or we can write simply 1. For clarity, I am going to write ID equals to 1, node 2, node 3, and node 4. Node 2 will be, if this is my x coordinate, y coordinate, and I am writing here as 0, 0, then the node 2 will be along the y dimension. This will be height. Node 3 will be its breadth in the x direction and height in the y direction. And the node 4 will be similarly breadth in the x direction and 0 in the y direction. So here I have defined the parameters. Here I have defined the modeling, and at the end I am going to send the data to Civil NX. So in our library, we have created a simple command called model.create that will send the data to Civil NX. Now let me move everything. There is nothing. This is a new model, and I am going to run this command. It has first set my model to kilometer units with this line of code. Next, I have defined the 4 coordinates 1, 2, 3, 4. I can see their node numbers, and I can also see their locations from the table itself. Now, suppose I want to change its breadth to 10, 10, kind of a square. And if I run the code again, the nodes ID, the nodes location are now changed. So this was my nodes. Similarly, I am going to define the elements. Now I will take this image back here again. So to model all these elements, I will be using beam. So element dot beam. Inside beam, we can give the node ID, the ith in node ID, the jth in node end ID, the material ID, the section ID, and beta angle. It's a structure group and some additional parameters. So for the beam 1, it connects node ID 1 and 2. So I can write 1, comma 2. Its material and section ID are 1. That is default. So I will leave them and I will make this ID as 1. Copy it, paste it again. So for beam ID 2, it connects element 2 and 3. 2 and 3. And for beam ID 3, that is this one, it connects nodes 3 and 4. If I run this code again, now here we can see the elements are getting generated. So nodes are creating, elements are created. Let's look at the materials. To create material, we can just type material dot, and we will go with the concrete one, the concrete. So name of the concrete material will be, let's say, M30 concrete. This is my name. Standard. So So since MIDAS Civil has built-in standards, the same has been reflected inside the library. So we can scroll down, select this IRCRC and the database. So M30, this is the codal name. The first one was name of the material. So we can choose any name. This is concrete. This is the database and that's why it has to be in M30. Material ID by default takes 1. So, and if I run this command again, this concrete material is now defined in my model. I can right click, go to properties and see this is the IRCRC standard that is mentioned here and M30 concrete M30. We can change it to, let's say we want to change it to M65. We can edit the code here, M65, run it, and the material is now changed. So this single line of command creates my material. Now for section dot. So since MIDAS, if we go to sections in MIDAS Civil, we have multitude of sections. So DB user, AC type section, paper type section, steel composite sections. So we have all these different kinds of section. For the time being, let's say we want to create a DB user section. Select pipe type, enter any data value. So dia 1, thickness of 0.2. So suppose we want to create this section. So we follow the same procedure inside Python. We go to civil section dot. We have went to this DB user, clicked on DB user. Let's say enter name of section as my frame sections. The shape. So this is where we select the shape. So here we have the angle section, channel section, I section, T section, and solid rectangle, solid round sections. So for the pipe section, the name is P. We selected the P5 section, comma. We enter this parameter. So the first parameter is this outer diameter, let's say 0.5. Second parameter is its thickness of wall. So we put 0.1. Let's close it and run the command again. Here we can see our pipe section. If we replace with SB, that is for solid box, that is a rectangle section, and run the command again. This one will represent the depth, this one will represent the width. So now this section has been changed with a rectangular section. So at this point, we have created the nodes, we have created the elements, we have assigned the material and the section. The way the section and materials are assigned is because if no ID is being provided here, the ID is automatically taken as 1. And in the elements, we have not provided the section and material ID. They were default 1. So that is why the ID are being assigned correctly. Next, let's create the supports. So to create supports in Civil NX, we have to go to boundary, then define the supports option. Similarly, we will write the boundary dot, use the support option. Here we have to enter the node ID. If we take a look at our diagram, we can see the node ID 1 and node ID 4 will be our fixed ID, fixed ends. So node ID 1 will be my fixed. Here we can either write fix directly to fix them or enter a string that represents the constant. So dx dy dz. So I can write 1 1 1. This 3 represents the dx dy dz constant, and the next 1 1 1 1 4 1 again for the rx ry rz and rw. This is for, and this is for the fourth and fix. Both of these options are fine for the fix and condition. If I run this command, I have created these supports. The next will be our loadings. To define a loading in Civil NX, we usually go to load, create a static load case. Once the case is defined, we can apply any nodal load. We can select a node, we can apply the nodal load. So first we will create a load case. So to create a load case, we have to type load case bracket its type. So I'll make it as dead load. So its type is D, name dead load. So with this line, load case is defined. Next will be my nodal load. So if we take a look at the diagram, we can see the nodal load is being applied at node number 3 in the -x direction. So we can write load dot nodal load. So this load will be applied to my node number 3. The load case will be my dead load. There won't be any load group. Load groups in Civil NX are mostly used for construction stage analysis. And now I can apply the loads. So Fx will be minus time the loading that I am provided here, P load, P load. That's all. Now if I click on run again, create section, nodes, element, boundary conditions, load, done. So right now I have a model which supports with a static load also. So once I have sent the data to Civil NX, what I can do, I can use model dot save or save as command to save it. So I will use save as command and a location. Let me check. Top, I can see the model is saved. If I again go to the folder, you can see the model is now saved here. Finally, I can write model dot analyze. So now the model is analyzed. I can do right click, reaction, view the reaction in my viewport, 7.5, 7.5, go to deformation and view the deformation in the viewport itself. So till here, any doubts? Like we have done mostly the pre-processing, that is creation of a simple frame structure. And the way I have adopted is defining each node individually, each element individually, and then applying the loadings on them. Like any doubts till this point? Yes, Prakash sir.
Yeah, I would
Hmm.
like to ask here you have given height equals to 10 meter. I mean, height is considered
Yes.
as a variable and you have given it 10 meter. Let's
Yes.
say I want, instead of just a single element, I want 10 elements,
Hmm.
1 meter each. So is there a faster way? For example, if I can write for loop or
Hmm.
do loop
Hmm.
to make
Okay, sir.
10
Yeah.
elements, 10 vertical element.
Okay, so
Yeah.
I will just in this PPT, in this pane. So your aim is to create something like this. Am I correct?
Yes,
Or
yes,
or
exactly.
you
Through
want to
for
create
loop, yeah.
multiple, or
No,
you
no,
want to
no.
create
Just
kind of.
just 10
Okay.
10 elements for a
Okay.
vertical single vertical element. Yeah.
Okay. Okay. Sure. Yeah. So
Where you
I
can
use
divide you where you can define let's say you define a spacing x
hmm, hmm,
and
hmm.
you can say that
Correct.
we have a height of 10 meter when uh, h divided by x it becomes 10 element or 10 node and then you apply for loop and
Okay.
this is how it goes on. Yeah.
Okay. Sure, sir. So yeah. So is this sir? This one is clear, na? Correct. This is simple one. I
Yes.
have defined all the nodes manually, everything.
Mm.
Okay. So this one. So the newer one, I will define, as Prakash sir mentioned, I will define this and again input, let's say, number of divisions to divide it or a mesh size or size of the meshing. So I can go with this approach. So paint one. So in our library, to create the beam elements, we have multitude of functions. So if you go to our library element, 1D element, beam element. So to create the beam elements, we have used the first one, this option element dot beam, where my input was the node ID of I and J. This is quite useful when we know the node ID. But in this scenario, let's say we want to create a node here, we want to create nodes somewhere here, we want to create nodes somewhere here and here. Node ID is 1, say 2, say 3, say 4. So then we need to create a loop to create these multiple nodes and again create a loop to create multiple elements. So we need to write these two loops. To simplify this process, what we have done, we have created our built-in functions. So the function that I will be using is called beam.se, beam.se function. So how it works, SE means start and end location. So I give a start location in XYZ coordinate, I give end location in XYZ coordinates, and then I give a number of divisions, how these beam elements will be divided. So as an example, so this is a new file. I will create a new one here. I will create one start location. This will be XYZ coordinates, so 0, 0, 0.
इसने कर
This
दिया
will,
admit.
so this will be my end coordinate. Let's say in height, this will be. So if I use my element dot beam dot se command and use this start location and use this end location and number of divisions. For example, I want 5 divisions at the moment, and at the end, I will use this model.create command. Delete this. And if I run it, So here we can see that it has created node 1 at 0, 0, 0, node 6 at 0 comma height means 0, 10, 0, and then it has divided into 5 equal elements. So 1, 2, 3, 4, 5. So 5 elements are created. So now with this approach, we again go to the pen. We again start defining this coordinates. So let's say this will be my point 1, 2, 3, and 4. So this will be my, let's say, PT1, 0, 0, 0. This will be my PT2, my PT3 will be at, let's say, breadth 0, and my PT4 with breadth comma 0, comma 0. So now I have these 4 points. I can use it to connect PT1 to PT2. So earlier I was using this node IDs. Right now I am using the locations and divide them by, let's say, 10 divisions. Similarly, the next will be PT2 to 3, 3 to 4. And if I run this command again, I have this portal frame with multiple elements. So here you can see that there is no node definition. So here we are defining the location of points, elements with divisions. So for this one element, let's say the first one that connects this point 1 and point 2, I am using this 10 divisions. What we can do, we can just put here integer of whatever the height we have, it will convert it to the nearest integer and then give me height dimension. So if I change it to 20 and run it, this side will have 1 meter spacing while this one will have 2 meter spacing. So I can copy and paste it here, here, and this will be my breadth. So the top one will be the size will be based on its breadth. So we can change all the data again. So 10, let's make it 5, 8, print again. So I will have 10 elements. That means total 11 nodes in the vertical ones. Here I will have 8 elements, total of 9 nodes. And again, I will have 10 elements again here, total of 11 nodes. So this is with divisions. So now I will have structure ready. I can copy and paste this part that defines the material. Run it. Now coming to the supports. So in our earlier example, we had quite a very good idea of what the support IDs will be. But here, since the first one, we can be sure that this is one, but the last one's node ID is quite difficult to estimate. So we have another option. We can use this node, this location will be my 0, 0, 0, and whatever the node that is present there, dot ID will returns me its ID. So suppose I want to know what is the node ID of this one. So I can write node its location x comma y comma z dot id to know the id of any node that is present at this location. Using this concept, I can write again boundary. I can use this boundary dot support. So the first one is my node location for id point one. So I will copy this one, paste it here. So this is the id for node at 000. Similarly, this one be node at location this fourth. That is this one. Now if I run it, so I am using this built-in function of node, its location dot id. I can also arbitrarily, let's say, enter this node point. So this is the node corresponding to the third point, that is this one. If I run it, my support will be created here. So I have created the support. Similarly, I can copy this whole code again, paste it here. So load case will be same. Now in the load nodal load, I want to apply the load here. I can copy this node ID, paste it here, and put this as height. Run the command. So this is our portal frame with variable meshing size. So if I change my element numbers to 10 to 20, my number of elements will be changed, but the supports and the loading will be consistent. Now, just to finish it, I can copy and paste this one again. Portal frame underscore 2. So in my folder, there is just this portal frame model file. If I run this command, so it is saved. Now it is, the analysis is running and it's completed. Right click, I can again see the reaction. I can again see its deformation. Now since I have much more nodes, I can clearly see its bending. So any questions, sir?
Yeah, I have a
Hi, Sammy.
question.
Oh, okay.
Yes.
Oh,
Go ahead, Sammy.
yeah, so my doubt is like here you have provided a mesh size of 1 meter, and
Yes, sir.
that's why you have given as integer height. So
Yes, sir.
instead of 1 meter, if I want to put 0.5 meter as the mesh size, so
Hmm.
what will be your input? Height into 2?
So height times 2, or
Okay.
I will just, so the better option will be an option of, let's say, mesh size.
Okay.
And I am using this zero point 0.5 right now.
Hmm.
This will be height divided by mesh size, breadth divided by mesh size, height divided by mesh size. Whatever I am getting as a
Hmm.
float value, I am putting rounding it to nearest integer because that is my whole number. This is my number of divisions. So this should
Yes,
be a whole
yes.
number. Yeah.
Or
So
we can
now,
even give in a digit, right? Like 20 or 10 that we
yes,
can
yes, yes,
provide.
yes.
Okay.
Yeah. So I will delete it. And right now this is mesh size zero point 0.5. So 10, 5, or let's say 5.5. If I run it, it is saving the model and running the analysis. I can go back, go to apps, query, nodes. and I click on this first and second node. So here I can see the distance from node is 0.5. That is
Yes.
because we have a mesh size of 0.5. I can change it to 0.25. Run this code again.
Okay.
So if I go to nodes and tables, we can see the first one is 0, 0, 0. The next one is 0, 0.25.
Yes,
The
yes.
next is
Understood.
0.5.
And also the result output, every time we have to see it from the graphical user
So,
interface,
hmm,
or we can
yes,
see it in the Python as
no,
well.
sir. So, yeah, you can see it in the Python as well.
Okay.
So, for this one, I will use this simpler example because the number of nodes are quite less.
Mhm.
Any other questions? After this, we can move.
Yes.
Can you repeat, Magdi?
If you are making several requests, so
Hmm.
model create, as I understand it, make batch request, right?
Yes, these are in
So
series
the
actually.
series.
Uh,
Okay.
yeah, I will show. So this internally model dot create internally executes, let's say, this section dot create, material dot create, thickness dot create, node dot create. It
Okay.
internally executes all this in a series.
There is no method to create in parallel request, right?
No, no, no. Next request can only be processed when the first request is finished.
Ah.
Hello, Islam sir. Any question?
Okay. I had a question about the labeling. For example, if I want to have a special label for the control nodes, the one where I start and end each element, how can I do that? I'm talking about the ID that is in the Civil NX itself, not in the script.
So you want to control the ID of the nodes.
The ID for PT1, 2, 3, and 4, yes.
Yes.
A special
So
label so that it would be clearer for us.
okay, sir. So if you want to create position like this, so before creating any element using this element dot AC, I can use, let's say, this location. So 0, 0, 0. Now I'll put its ID as, let's say, 100 or say 500, for example.
Does it have to be a number or it could be
Uh,
words or letters?
no, no, sir. It has the ID has to be word. Okay, a letter actually. Int only int part has to be ID. But if you want to label it with respect to a name or a string character, then we can
Yes.
use this group function. Group equals to. I will use the group function. Show you how to use group functionality here. So model.create. I will delete this one. This is my node, and I will call this group as group equals to, let's say, bottom support or support. Similarly, this last one will also be in group called support, and this node, the third one, will be in a group. We call them as loading group or load node.
Okay.
So I am. Hmm.
Yeah, yeah. Also, one more thing. For example, if I want to define a group or add a node into a group, do I always
Hmm.
have to يعني write this group after the definition of each node, or can I do it separately in a separate row?
Yes, you can do it separately. So you can group dot. These are actually structure groups. So group dot structure. It's the name of the group. Let's say support, and add this node list or element list directly here. This will add to the existing group.
Okay,
So
okay.
yeah. So right now I am defining this node 00 in support, all these nodes, and for the time being, I will disable all these things, the supports to sections, and only run these parameters. So here you can see it has created a structure group called support, which has two nodes. If I double click on it, I can see the two nodes. If I double click on this one, I can see this load node. Now, when I come to the support, now instead of writing this one here, I can write node in group and give the group name as support and delete this one. So this gets all the nodes that are in the support group. So it gets me the two nodes, and I am applying a fixed node condition to these two nodes only. Similarly, I can come here and here apply nodes in group, and I can write its name, that was load node. Load node here. Save it. Run the command again. So I will now have my supports here, the static load here, and all of these are controlled by these labels. So at any point of time, let's say this node does not have any load assigned. If I add it to group equals to load node, if I add it to group load node, run the command again. Now this node should have a loading, or if I change its group to say support again, this should now have a support. So I'm controlling the support condition or the loading condition via this group tag. So does this solve your like query, Islam?
It's about Excel, Microsoft Excel and AutoCAD.
Okay.
So is there any way possible that we could work in dev actively with it, with Excel files or with CAD, so that, for example, we wouldn't have to define each node one by one or elements, and we could
No,
just يعني
you can import the alignment from through DW file or DXF file. So Python has a library called EasyDXF that can read that. And once you have coordinates, you can create any alignment. Okay, so your question is mostly related to creation of alignment, correct?
alignment. Well, it doesn't have to be. For example,
Alignment or any.
for example, if I have a set of lines or polylines in a CAD file, okay, I need to create the joins at the start and end of each line, okay, and then implement all of that into the MIDAS Civil. How is that possible?
So
You
first.
you don't have to يعني response to all of this. I know it could
Yes, yes.
be a big topic,
I
but
will respond.
we can just give us an idea. Yeah.
Yeah. So so this one has a library called EasyDXF. Okay. So this library actually allows us to read the data from a DXF file, or read or write a data from the DXF file actually. So with this library, we can get the list of polylines, find out their end nodes. Once we get the end locations, we can again utilize this kind of formulation to create the nodes.
Yeah.
So I will try to find something that imports a DXF file and create this kind of polylines arrangement. Okay. For Excel, this is same. So if you have Excel, you can read and write from a certain cell locations and control the Python file, control the variables in Python. Okay.
Okay. Thank you.
Yeah, I will right now this one support notebook. Yeah, so this is our one kind of a final portal frame. with 4 nodes and one applied node. Once we have all these things, so we can extract the data in the same file, or we can create a new file, let's say sp.py, and this one we only use it to extract the data, because creating the model again won't always be our choice. So I have connected it to this Civil NX. I will now analyze the model.analyze. Now I will use, let's say I want to extract my reaction table. So result dot table dot reaction, and that's all. So if I am providing nothing, it automatically takes all the reactions for all the load cases. I am calling this res arcane table, and I am printing this table. So here we can see this tabular data that we have obtained. I can go to this reaction, open it, and try to match it. So 7.49, 7.5046, 7.5046, MZ value minus 42, minus 42, minus 42. So with this single line of code, I have extracted all the tabular data, and I have a bunch of options here. I can enter the keys represents the list of node IDs, load cases, any component. So if I want only the DX component, DY RX, RY, or moment component in presence of construction stage, I can have that. And type represents either I want the global reaction or the local reaction. And finally, we have these options. So table options. I will show you what table options does. So right now, this is my folder structure. I have three Python files, some MCV files, and their analysis. I have put the Excel file location as some option. Run the code again, and at the end here I got one test.xls file. If I open the XLS file, I'll find the same data in a tabular format. So if I got again, let's say beam table equals to result dot table dot beam force, run it again, and if I go color again, and 1 second, it has updated it, so delete this one. So its default behavior is to edit the existing one. So that's why there were two nodal table. So reaction table, beam force table. So to get this output, we just had to write this single line at the top. This makes any command that follows any zero table command output this data in this Excel sheet. So I can write here test2.excel sheet, test1.excel sheet, run it again. It will make me two Excel sheets now. Test1 and test2. Test1 only for the reaction. Test2 only the beam force data. So if I switch the model to a complex one like this, run the analysis again. So it will create the model. 1 second. Now, created the model, run the analysis. I can switch to this one. Yes, A2, A3, run it again. So I am utilizing the same code that works on the previous one to extract the results. Now again, I have the two reaction table because we only have two supports. But if you go to here, the beam forces data, we now have multiple options. So this is all corresponding to all the beam members. I in chained of, let's say, node element ID 60, element ID 1. So this is how the result extraction can be done with this line of code: result.table.reaction, result.table.beam force. Now, for reference, if you want to know how all the functions, you can go to results. This is our Python library help manual. You can go to the result table. Here you can see the different parameters of the table options, the Excel file location. We can even change the Excel sheet name, where the data should be written, the Excel cell position, the result table method. So we can get the reaction, the displacement, thrust force, beam force, speed forces, and if you are using for buildings, we can get the story displacement and drift. So all these tabular data can be extracted. Yeah, Prakash sir. Yes.
Just to ask,
Ah,
let's say if instead of having all the reaction, I just want FZ. Is it
except
possible to have only one reaction?
yes, sir. Yes, sir. So
Okay.
I have the components. So inside the components right now, if I go to, let's say, MIDAS civil and the reaction. So here, when we are seeing on the reaction table, we can see node, load cases, the fx, fy, fz, mx, my, mz. So we can have much more control. So we can write node, we can write load, we can write, let's say here, we are only interested in say mz. I can write mz here, node, load, mz. Okay. Now if I comment this out and only try to get the reaction. So here the table that is being printed will only have this node, load, and mz. If I try to remove the load, and in any case there are multiple loads, it will cause a crash here in the Python, because for the same data there will be single input, single entry. So
Mhm.
node, load, mz. If I change it to, let's say, fz value, my, run the command again, we'll only have my. And if I in the Excel sheet writing, now inside my table I only have this my column. So is this okay, Prakash?
Yes,
Yes, sir.
thank you.
So any doubts till this point? Like, this was the first intro session. So I tried to keep everything bare minimum with this the first one approach, where I have defined all the nodes manually, all the elements manually, and defined everything by its ID. In the next approach, I have parameterized it and tried to make its division along the height based on the size, or or inputted directly a mesh size. And later, we have controlled the position of our support via either via this node ID or via this group tag. So these two approaches we have seen right now. So any doubts in all of this approach? If not, then we can end our session. And tomorrow we will continue from here and see how we can parameterize the modeling in more ways.
Yeah,